Okay, so the next topic we have today is data storage and sharing best practices. Um, this information, you're going to need in order to set up your, workflow a little bit in terms of, let's say you're doing some data analysis, you probably need to bring your data in from wherever it is, or you are in a situation where you're going to be creating a lot of data, different training data or whatever, so you need to know where to put it. So we're going to talk about data at NERSC. Um, excuse me. The original content is created by Lisa Gerhardt, who is kind of one of the data experts here at NERSC. And so I'm presenting a lot of, well, most of her content. Some of the stuff, there is some things that are a little bit more on the advanced side that you may not need to worry about as a newer user or if you're sort of a novice user. So if you have questions, please feel free to put them in the Q&A and we'll get, between all of us experts in the room, I'm sure someone will be able to answer it. But if you have some really fantastically expert level question, we may have to reach out to Lisa later and get her opinion on the matter. Um, okay, so the first thing we're going to do is go over the different file systems that we have. Um, so you've seen this earlier today. Perlmutter consists of all different parts. It's the sum of many parts. So there's sort of the compute aspect. This is where all the calculations are happening. But then there's places where you need to actually store information. So remember, memory and storage are different. Storage is where you put something long term where you can go and access it again later. And so we have a couple different storage options. One is kind of what we consider our local storage option, which is called Scratch. It's an all-flash system. It's 35 petabytes, and it is connected. It's basically hardwired into the system, so the data rate that it can handle is 5 terabytes per second. So this is a huge amount of data. I mean, terabyte is massive, right? So because it's local to where the computation is happening, it's the most performant, meaning if you're running huge calculations and you need to be storing tons of data while the calculation is happening, or you need to be doing a calculation where you're reading in tons of data, you will want to have all that data either stored or being stored in Scratch, and that's called Scratch. So we're going to talk about that more, but just as an overview. And then these are what we call our off-platform storage. So these are connected to Perlmutter via the internet. And the internet is provided by ESNet. So this is also a Department of Energy, Office of Science, I think it's Office of Science, program. And they basically provide a really, really fast speed internet. So like I was saying, my internet at home is like 1 gigabit per second. This is, 400 gigabits per second. So this is like crazy internet speeds, which you can't really get as a as a consumer. But even just by virtue of being connected over the internet, it is going to be a little bit slower, actually orders of magnitude slower than the local system Scratch. So we have sort of three different options. Some of these are more storagey, and then some of them are more just like a little landing place. That's home. We're going to talk about home in a second, but there's a tape archive. So it's exactly what it sounds like. You have these little cassette tapes with magnetic tape that store information for you. It's an archive, so it's meant to be something you keep for a long time. And then we have a common file system, or sorry, community file system. I think now it's called community file system. And this is the file system that you share with other people in your project. So if you're sharing data with, your collaborators or something, you would want to store data here. And you can also see the data rates here are a little bit different. So in general, you want to be using one of the storage options that has the best data rate. And so after Scratch, the second best one is the community file system, CFS, which is 100 gigabytes per gigabits per second. Yeah. Okay. Um, so again, like I said, you'll hear some of this information several different times, and it's all kind of trying to drive home the same point that there are different file system options, and they kind of are used for different purposes. And so there isn't, some cases, there's a very clear, like, this is what you should use this for, and this is how it's used. But then in some cases, there might be like a, well, you could put it here, you could put it there, and it might be kind of similar. So in general, the way that this is stacked is if it's at the top of the slide, the performance is better. But if it's at the bottom of the slide, the capacity is better. But that's for this section right here. This section right here, these two, global common and global home, are a little bit different. And again, I'm during this presentation going to talk about every single one of these in more detail. Um, so memory, that's talking about the memory on the nodes. That's not storage, right? It's used during compute. So the kind of next best thing would be the Scratch file system. And I think these numbers are a little bit different based on like when I updated these or when Charles updated them. I think there is about 35 or 36 petabytes of SSD Perlmutter Scratch with 5 or 6 uh, terabits per second, terabytes per second. This is bytes. This is a data rate, so it's bytes. Um, uh, in terms of the speed that it can handle data coming in. But again, and I'm really going to drive this home because it's really, really important to remember this. I'm going to say this multiple times. Scratch space is temporary. It is not a permanent storage solution. So if you have data in your Scratch and you need it for a year, 2 years, however long, well, your project is probably a year, but if you continue on, you're going to need it for longer than that. You need to move it from Scratch because it could get purged. And we'll talk about what that means and how that is determined in a bit. Then we have the community file system. So this is, again, and like I said, some of these numbers are a little different based on like probably different benchmarks that were run or something like that. Um, but it's around 100, 150 gigabits per second. It's, again, a huge storage space. So this is about 115 petabytes, and this is permanent space. Um, because it's not SSD, the rate's slower, but it's permanent, and you can move your data there once you're done creating it or analyzing it or whatever from Scratch. So you have it in Scratch while you're actively using it, and then you can move it into the community file system. It's still really fast. So for a lot of your applications or what if you're using this data just to run some simple calculations or something, you may not even really notice a huge difference. I think it really depends on the application and how optimized the application is. So I'm not going to say that totally broadly, but I bet there are situations where you may not even notice a difference between using Scratch or the community file system. And then the next, and this is the largest space, but of course then the slowest, and there's no sort of data rate here, I guess. I think there was on the other page, but essentially this is where you put data once you're done using it and you need to keep it. It was data that was used for a paper you wrote, the paper got published, but of course you don't just throw the data away, you got to keep it in case anyone else needs to see it or you need to check something again, but you're probably not going to be accessing it very often. And so it's really meant exactly as it's described as an archive. You have this tape. Tape is extremely stable. Any kind of, it's not, so once it's written to tape, I mean, it's as long as it's kept in a certain environment, and maintaining that environment is not super expensive in terms of like, the temperatures or whatever, right? So it's super stable and it can be kept easily for a long period of time. Of course, physically it takes up more room because it's like a physical tape, like a cassette tape type of thing. If anyone knows what a cassette tape is, I'm 32 and I used to have cassette tapes, but I don't know, some of you are much younger than that. Um, but it's a physical object that takes up space, but so that's kind of the downside. I mean, SSDs take up space, but they take up significantly less space than like a one tape. But the upshot is that it's super stable. And then we have some common spaces. These are our global common and our global home. These are permanent, but they have different sort of uses. And so I think I'm going to wait until I get to those pages to talk exactly about what those are. Um, okay, so in general, just to understand, we have all of these different options and, what exactly is it like, why am I telling you all this? NERSC is a user facility, so we are sort of mandated to provide certain things for our users. And one of those things is basically we need to provide not only compute, so, a computer that can do stuff, but we need to provide you a way to store, manage, and share any data and products that use that data. So that's why we have several different options and different things that do different things because not only do you have to store that data, you have to manage it in certain ways. Um, your data is intended, we will, again, store, manage, help you with all of that data while you have an active allocation. So most allocations are 1 year long, not calendar year. It's like the fiscal year. So, or sorry, it is calendar year, I think. It is calendar year. I apologize. Um, but for example, and this might be true for even some of you that are leaving at the end of the summer, if if you're not sure you're going to remain in contact with your advisor, your advisor's project manager at the end of the year, we are not going to keep your data indefinitely. You are responsible for moving that data, keeping track of it, and so forth. So it's really important that you understand data is not going to live at NERSC forever, and that you need to move it, transfer, take it with you if you leave. Um, let's see, requests. So yeah, PIs have different powers than you. I don't think there's any PIs and probably not too many PIs, if any, in here right now, but the PI of your project can uh, have some special powers, and if they need help with that, they can always reach out to us and we can help them with those kinds of things in terms of moving data, finding data, deleting it, so forth. Um, was there a question? Question? Okay, I thought I heard something. Um, okay, so the way that files are, protected is with Unix file permissions. So if you attended our HPC Fundamentals course, we talked about Unix file permissions and how to change them using chmod. Um, but there is it is the responsibility of the user to ensure that the permissions are set up the way that you need them to be. And again, we're going to talk about different ways of sharing data. So, if you don't want to change your file to be, world readable or world writable, but you need to share it with like one person, there are ways to do that that don't require you changing the permissions entirely. Yeah, so in general, we are always here to help you. We're always here to answer questions. Managing data is really important. But ultimately, it is your responsibility as a user to understand, like, hey, I have this data. It's really important that I take it with me. It's really important that it doesn't get deleted. Like, where can I put it? How can I protect it? And so we provide tons of resources. This training is one of them. We're going to try to explain everything as best we can. But you have the responsibility of following up if you are not sure how best to manage your data. Okay, so let me talk a little bit about two of those file systems. If you remember from, oh, I'm not going to go all the way back, but there was two they were called Global Common and Global Home. And these are actually home is where you land this once you assign into Perlmutter. If you're just logging in on the login node, you're going to land in your home directory. And this is, so if you haven't seen yet, and Charles, welcome to link, there's an absolute beginner's guide. And the reason I like it is because I wrote it. But in that absolute beginner's guide, I use an analogy of a house to kind of explain the different parts of NERSC. And the home space I kind of describe as like the foyer of this house, where you enter the house. So it's like the little, if you enter the house, there's like a little bit of space to maybe put down your take off your shoes or, hang up a coat or something like that. It's a really small space where you can keep a couple things, but you're not going to sit there and, read a book or do an art project or something like that, right? It's not enough space to really do very much. So everybody has one of these spaces where you kind of enter your house or apartment or room or whatever. It's a permanent space. It's always there. You can always access the stuff there, but it's a really small space. So it's not meant for you to be running jobs out of. And what we find is because it's the place that you land when you first get onto Perlmutter, a lot of people tend to just run jobs there or try to keep a bunch of stuff there. And that's not what it's meant for. It's really meant for um, just a very small amount of things like some source codes, maybe some shell scripts, text files, just small things that you maybe need to refer to, templates for job scripts, things like that. Maybe some Slurm out files, those are text files, they're really small. So nothing big, okay? And you access that by using, so if you're on the command line, CD is change directory, and this means this is a variable that's stored at like an alias. Actually, it's not an alias, it's a variable that's stored that will take you exactly to your home location. So your specific home location, right? Because everybody has their own. And so if you need to find your home, if you're not there for some reason, again, you land there when you get on Perlmutter, but if you move around, if you need to get back, you use CD home with the $ to get back. Um, then we have the community file system. So the community file system, now this is a big space. This is where we recommend putting larger things that you need to keep for a longer amount of time. So this again is permanent. Things are, and by permanent, I mean it's while the allocation is active. So while the project exists, which is usually a year if it's not renewed. So it's permanent as long as the project exists, not permanent in terms of like forever and ever. Um, Medium performance, I mean, it's still very high performance. So if you are in a situation where you're wanting to run a job and you need access to a huge amount of data that lives in CFS, you can run a job out of CFS. And it will still work really, really well. Maybe not quite as well as uh, Scratch. Again, depending on the application, depending on the size of the data and how the data IO is set up, you may or may not see a difference in performance using CFS versus using Scratch. But really, the idea of CFS is that it's perfect for sharing data within your research group. So I don't remember all of the like default permissions, file permissions in CFS. But they're probably group like readable or something. And then you could change them to be like group, I don't know, executable or something like that. If you're the rest of you, if you're trying to show or let your other research partners use it. The way to get to, well, so this will actually get to the CFS, kind of like all of the CFS projects. So you would do CD and then this variable CFS, and then actually you would need to have a backslash and then your project name. And I think I show that command on another slide, but not here. So I'll show you specifically what that looks like to get to the community file system space associated with your project. And then there is Scratch. So again, kind of saying this information over and over again, Scratch is extremely, well, let's see, it is a large space. Everybody gets 20 terabytes to start. So that's actually a lot of space, but it is temporary. Okay, it is not permanent. Um, the reason is it is highly optimized for read write. And so in that way, it's a short-term storage while you're running something. So like while you're creating data, while you're doing data analysis, while you're doing some kind of complex computation on a whole bunch of data, it's meant to be used very actively. And then there's a purge policy which says if there is a file that has not been opened, used in any way, accessed in any way, it is subject to be purged. So not necessarily it absolutely will be, but it's like in line, like it very well could be purged from the system if it hasn't been touched or used in about 8 weeks. So you have basically a 2 month buffer, but don't let that 2 months get away from you. Like if you're done using your data, or if you're done using Scratch, like you've made your data or you've done your calculation, move it to keep it safe. Okay. So it's meant to be used for staging data and performing computations, and you access that by doing CD and then Scratch. That's the sort of variable that has the file path saved in there. Okay, any questions so far?
And I want to emphasize how important it is for you to make sure you back up your Scratch data. I get so many tickets where users are like their data is gone and we don't back it up on Scratch. So it is your responsibility. If you need those results from your simulations or any jobs, please make sure you back them up.
100%, totally agreed. Again, HPSS, this is our long-term storage system. This is the archive. It is, um, uh, so we call it HPSS, High Performance Storage System. It's for data that's accessed really infrequently. So you should not be like again, the main reason for storing data here is you need to clear up space in your CFS. You're done writing your paper. It's a huge amount of data, and you need to keep it for the next 5 years in order to comply with the journal you've submitted to. They need you to keep data available for a certain amount of time, maybe longer than that, I don't know. But it just needs to be kept safe and kind of out of the way, and you're not going to be accessing it often because this will be very like you don't want to be reading and writing and reading and writing to tape. And they're not meant to do that. I think, I mean, you're physically, I don't remember having a tape where it's, you're modifying like this physical tape every time. And so I think it can wear, right? So you're really not supposed to be doing this like over and over and over again. At least that's my impression. I don't know, and we'll have to ask the tape experts. Um, so yeah, so there's yeah, I'm not gonna get into this because I don't totally understand what this means. But uh tape archive, you can read a lot more about it on our documentation and how to use it as well. Okay, so let's see, what do we got here? Okay, so let me see here. Yeah, so the main thing again, this is reiterating that Scratch is used for data that's being actively read or written. The directories are user readable and writable by default. So again, I actually, and I always mean to look this up and then I completely forget as soon as New user training ends. But I think you can change permissions in your Scratch so that they are like readable by other people. But I like don't remember how that works. Can you just share files from Scratch with other people? Does any of our other experts remember how that works?
I believe so.
Okay.
And there are a couple of other tricks you can use for sharing files as well, but maybe
Yes.
it's a little bit beyond the scope of what we want to discuss.
Yeah, I'm going to talk about one of those utilities, the give and take in a few, but I
Okay.
think
Yeah.
there are also ways that sometimes instead of using that, you can just like change the permissions. But again, I always forget to like double, triple check that.
Okay.
Um,
Yeah, I was referring to, yeah, the take. So give and take.
yeah.
So yeah.
Yes, yeah. So we'll talk about that in a moment. Perfect. Thanks, Charles. Yeah. Again, if you haven't heard us say this 1,000 million billion times yet, it is purged. It is not backed up. Please save your data. Um, so quota means like how much space you get. And when I say soft and hard, this is like soft is like, so if you hit 20 terabytes in your Scratch space, I think there's so when it says soft, I feel like there maybe is a little bit of like rollover. So like I don't know what happens if you like try to save 21 terabytes and I think it'll let you. But I don't totally remember that. But the other thing that soft means is that you can request more space. Oh, but you can request more than 30, right? You can go up to like 60. Okay, so I think what soft really does mean here is like if you're running something and it tries to save 22 terabytes, it will let you until you hit 30, and then it really won't let you. Then it's like, no, you really need to request more space from like you need to talk to NERSC and get more space if you're going to be using more than 20. So I think at 20, maybe it's gonna like maybe it'll try to like flash a warning or tell you like, hey, you're kind of going over. But at 30, it'll literally be like, you cannot write any more data here. If you exceed this, you need more space. There might be situations where you do need more space. That's when you're going to request a quota increase by using the form that I showed you in the previous presentation. So you're going to contact us and you're going to say, hey, I'm running this data or running this calculation. I need to produce data. I think it's going to be about 50 terabytes. And then as soon as I'm done with it, I'm going to move it somewhere else, right? Or, once I create the 50 terabytes, then I'm going to run my calculation over it and it'll reduce it to 20 terabytes. But I need to get to that 50 terabytes first, right? So there might be situations where you have to do something like that. You just can contact us and then we look at that at a case by case basis to give you more space so that you can do that. Again, there's a time limit. So it's not like you get 50 terabytes for the rest of your time at Nurse, but you might be like, hey, in the next 6 weeks, I'm going to be doing this. I need this much space for this amount of time. And usually we're able to accommodate that. Um, there's some information about striping. This has to do with like how the files are written. This is a little bit more advanced and I can't really speak to it, but if you know what this is and you need to access this information, it is in our documentation. Um, there was another sort of special space that was on one of our slides, which is called Global Common. And this is also an interesting, it is storage in that there are certain things that you might want to put in this space, but it is used kind of in a very specific way. So it's not storage, like you're not going to be putting data in here. Really what you want to put is like your software stack. And the reason for that is shown in this plot here. So let me explain what this is. So this is a benchmark. At different times you're doing a read action on something in various different locations in like on Perlmutter. And this is a pretty old graph, so this might have changed. But what it's showing, basically what you want is that time to be really, really small, right? You want the read to happen as quickly as possible. And so what you're seeing here is that if you put your software into, so Shifter is a container, and I don't think we really cover containers in user training, but at some point we will have a containers training, so you'll be able to learn more about that. But so if your software stack is in this thing called a container, it will be really, really fast. But the next best thing is to put your software stack in global common. So common is here, this black one, and you can see that, there are times for the most part, it's always faster than Scratch and even your project directory. So project means CFS. And the reason for this is because Global Common is mounted read-only on the compute nodes. So when it's mounted in this way, it makes it so that it's not expecting you to be like, writing data. And because it's read-only, it makes that process really, really, it's like optimized for that. Um, so it is writable. From login nodes, so you can write to it. So what that means is like if you have software, you have a executable, you've compiled your code and you're ready to run it, you can put it in Global Common Software. You can write it when you're on a login node. And again, we're going to talk, and we did talk a little bit about login nodes and compute nodes, right? Or maybe that was in the fundamentals course, but um, login nodes are where you land right when you uh, sign into Perlmutter, and then you go to a compute node, which is where you do your actual computation. On a login node, you could move your executable from wherever you compiled it into Global Common Software, and then because it's mounted read-only on a compute node, once you move to your computational phase, the compute part of your workflow, it will be super fast and it will help you the performance of your application because it's not going to be taking forever to access the libraries and the software and your executable while it's running. Um, so that's what Global Common is used for. It's really for software, sort of storing your software stack. Community file system, this is basically where you're going to move your data once you're done using Scratch. So we keep saying like you got to move your data, don't leave your data in Scratch. So it's very natural to be like, well, where am I supposed to put it? Again, you're going to put it in your community file system. This is your project directory. This is shared with other people on your project, but it is permanent as long as the project exists. So it has group read permissions by default, and the amount of space that you get is actually determined by the project. So and I think by your PI. So depending on what you're doing, your PI may need to give you a little bit more space. And you can check how much space you have. There's a couple different ways. I think there's some show quota, like those like command line tools that you can use on Perlmutter, or you can go in Iris. Because remember, Iris keeps track of all that stuff for you. So there's a couple different ways you can check and see how much space you actually have in CFS. To access it, you're going to do CD, and then again, this variable CFS, and then your project number. So if your project number, so for example, if you're on a training project, so for those of you who are like in HPC fundamentals, we had this training project. It was called TRN 010. So that was our project number. So I would do CD $ CFS slash TRN 010, and that would take me to my CFS space for the training project. And then I could make a directory for myself. Maybe I'll call it my name or something. And that way, for example, in your other project directories, like with your PI would be able to say, oh, okay, Libby's stuff is here. So if I want to go and she said she made a plot. I'm going to go look at it. They would know to go look in my directory or so forth. And again, it's readable, so they can go and look. In general, everything I'm talking about here, there is significantly more information online. So if you want more information, please feel free to go to docs.nurse.gov to look up more about the community file system. Um, okay, this is a little bit okay, so I can't remember. So okay, so like I was talking about with the global, what was your question? Okay. As I was talking about with the global common software, it is mounted read-only on compute. Um, there is a read-only mount of CFS, which is again meant to be very performant. And so if you need that extra performance boost, instead of using the global mount of CFS, you can use this GVS underscore RO, this read-only mount, and that will make your again that performance a little bit better. Um, Data is not purged while the account is active, and your allocation is based on your project. So your project, your PI will kind of give you different amounts of space depending on how they would like to break it up. Okay. Oh, this is a video. I'm actually going to skip this, but you can find this video of how HPSS works. This is the tape. I'm gonna skip this a little bit because again, you may or may not be using this summer, and the other thing is you will need to follow the directions in this docs.nurse.gov in the archive section. Um, so one thing I will say is that the data, if you do need to store something in HPSS, your PI asks you to do so. It's really important that you don't put like a million tiny files onto, if you have a bunch of little data files, you need to tar them. There's a HTAR, which is like the special HPSS tar action. You need to bundle it up, and so that they're larger files in order to store it properly. And there are special commands that are meant to be used in order to write this stuff to HPSS, HSI, and HTAR. You will find information in the docs about how to do that. Very good step-by-step information on how to do that. So if you're ready to do that, I highly recommend looking through this. And again, reach out if you need help. Okay, I mentioned home. So one really, really important thing to note. The home directory quota is 40 gigabytes. Okay, in chat, who can tell me quickly what is the amount of space you get in Scratch? Who's still awake? Okay, 20 terabytes. Exactly. So this is more than let's see, several orders of magnitude less, right? Just TB terabyte. Um, right, because gigabytes and terabytes are, I think the order of magnitude difference is like 10 to the 3 or something, right? So this is like vastly less space, right? So this is not meant to be storage of any kind. It's not meant for intensive IO. It's literally meant to just keep some little notes and scripts and so forth, right? You are not going to be putting huge amounts of stuff in there. It is backed up. So several of these are backed up, and you'll see if you go to our documentation. So CFS is backed up, HPS, CFS is backed up, Home is backed up, um, but for 7 days. So if you have something go wrong and you need to go, excuse me, like basically revert to an older version, you can do that, but within 7 days. But again, meant to be a really, really small amount of stuff. So again, 40 gigabytes. Um, okay, let's see. Doo-doo-doo. Um, okay. In general, okay, yeah, so we've talked a lot about Scratch. So we're going to talk about jobs and we're going to talk a little bit about Conda environments and so forth. But again, your Conda environments, um, okay, your Conda environments and your software stacks can all go into Global Common Software. That's going to be very performant. And and this is probably true in general. I don't know if it's just Perlmutter, but probably for a lot of systems like this, making a million small files is not good. I wouldn't recommend. You should find a way in your script, in your application, whatever, to be aggregating these and then writing bigger chunks. Because writing a million small files into one directory is going to cause problems pretty much no matter what. So if you find you're writing something like if you're developing your own script to, something in Python and you're saving all these little files, find a way to batch them up and save them all together. Um, okay, Charles, how are we doing on time? Because part of me wants to zip through some of these things. When would you like me to
You
wrap
know,
up?
take your time. You can do like 10 more minutes.
10
I
more
think
minutes? Okay, okay,
it'll take
sounds
me only about 20 to go through the Python stuff, and then we can
okay.
wrap up.
Okay, sounds good. So Perlmutter has this thing called DVS, which it stands for Data Virtualization System. I don't remember. Actually, the funny thing is I don't remember what the S is, but the D is data, V is virtualization. And you don't really need to worry about this, I don't think. But I'm gonna throw a bunch of information at you. The main thing, there's like a couple main things, and you may come across this. So there's basically two main things on this that I want you to maybe know about. Conda environments. Conda environments can cause problems if you're running at scale, if you're running a really big job and your Conda environment is in your home directory. This can cause a lot of problems. So if you are going to use Conda, if you don't know what Conda is, that's fine. Don't worry about it yet. You're going to learn a little bit more about it later. If you do know what Conda is, you know what a Conda environment is, you are going to want to make sure that you set this up correctly in order to make sure that your job runs smoothly. So usually the best practice is for your Conda environment to live, I think actually Global Common Software is a good place for it. Again, software stacks. Um, uh, can be kept there. I think that's probably the best. And I think the information that we have in our docs shows you how to set it up in Global Common Software. So you could make an environment in your home directory and then move it there later. But I would suggest using the instructions in our documentation page will tell you exactly how to set up your content environments so that they are not causing any issues. Um, so if you anticipate this summer, if you're a summer student, I know a lot of the people in this room are, but if you're not a summer student, this still applies. If you anticipate running large jobs and you're going to need a conda environment, it's important that you set it up in the right place. Okay, don't take this lightly because it can cause problems. In general, run your jobs in and out of Scratch. It's just going to be the best practice. It's going to make things easier. And then I will again remind you all, if your data is too large for Scratch and you need to run from CFS, which is fine. Sometimes CFS is, like I said, just as performant. You will want to make sure you're using this DVS read-only mount of CFS instead of the global mount. So the way you're going to do this is if you're reading in some file and you have some input script somewhere, instead of asking it to go and find the file or the configuration or whatever in global CFS, this is the full file path. You're going to ask it to look in DVS instead, and this should make things a little bit faster. Um, Great. And there's another point here, but I don't totally know what this means. So I'm going to leave it there. If this applies to you, if you know what an ACL is, or if you're going to be doing this, don't. Okay, so now let's talk a little bit about sharing data. So this could be sharing data with other people at NERSC, outside of NERSC, moving your data from somewhere outside of NERSC to NERSC, lots of different data movement. Okay, so a couple things. Every project has one of these CFS file directories. So if you need to share with someone in your group, the best thing to do is just put it in your CFS and then change the permissions. And then that way, if you're working with like again your PI, whoever, um, that's the best way. That you're not like sending any data over the internet and then having them put it back into CFS or something like that, just so that the permissions are different. And your PI can do this using PI Toolbox. This is a toolkit that we offer them that has special tools if they need help changing permissions. But you can also just change permissions using chmod. Um, HPSS is group writable, readable. Um, I wouldn't necessarily suggest putting data into HPSS and then reading it somewhere else in order to share it. Again, I think CFS is the better option, but worst case if someone says, hey, the data's in HPSS, you can go get it from there. Um, let's see. I'm not going to talk about collaboration accounts. Okay, yeah. So you can share data from scratch just by changing the Linux permissions, and the um, command is here. So you're going to use these change group and change I don't well, mod, I don't remember what mod is, but you're going to change the permissions to make it read only or so forth in order to share it or not unshare it or so forth. And then we have this really, really cool mechanism called give and take. This is probably going to be one of the best ways to share data. If you don't want to worry about changing permissions, which sometimes I don't necessarily want to do that, I can use this give and this take. And so the way this works is this only works within NERSC. So if you're just sharing data with someone inside of NERSC, once you've signed into Perlmutter, you're going to type in, let's say I need to give Charles a file. So I'm going to say give, and then -u is the flag for user. I'm going to type in Charles's username. So remember, I'm logged into my account and I'm giving Charles the file. So I'm going to type in Charles's username. So I need to make sure I know Charles's username. So if for some reason I don't, I need to email him or send him a message or text him or whatever saying, hey, can you remind me what your username is? And then I'm going to give the path to the file. And maybe you can share entire directories, but you probably have to do the directory and then /star. But then that's a way to give like a bunch of files. Probably don't want to be giving like hundreds of files all at once. I haven't done that. I haven't tried it. Usually just share like one or two files at a time. But this is really great because now I don't have to change permissions or anything. I can just, because then Charles would have to go and like copy it from my space. He'll get an email saying that, hey, Lippy, it'll say who is sending these files to you, and they'll be available for you to take them for a certain amount of time. And I think it's a pretty decent amount of time. It's like a month or something. So then what Charles will do is he'll log in to Perlmutter. He will say take, and then he's going to put in my username because he needs to be sure that he knows who this data is coming from, what this file is, where it's coming from. So he's going to type in my username, and then the name of the file. I don't remember if you can just do star for like take everything that Lippy gave me, but maybe you can. And so this is a really cool tool that is native to NERSC. So, this may not exist and probably doesn't exist at other HPC facilities, but is a good way to share data just inside of NERSC. I'm not sure that there's necessarily like a data limit of like how much data you can share by doing this. I maybe wouldn't be sharing like terabytes and terabytes of data, but maybe you can. I cannot tell you for sure. There may be some more information in our documentation about, you know, how best to use this. Hmm, okay. So there's a couple ways to share with outside people. So every project is given actually like a public HTML space. So you're in CFS, your project has this www. Well, you can make a www folder if you need to, and then this becomes a public space where people can download data. So this is just a way of putting data out there, right? So again, be careful. Make sure you mean to make this data public because as soon as it's in there by visiting this webpage here. Oops, sorry. This webpage here, and then your project number. So if you're sharing with a collaborator outside of NERSC, you'd need to tell them this information. But technically, it is out on the internet, so anyone could actually access this data. So hopefully, it's okay for it to be completely public. That's one way to share with data outside of NERSC. We have a way of building science gateways. These are basically like portals that allow you to share data outside of NERSC, and you can actually make really sophisticated web applications. So this is a cool way to make like cool websites where like maybe you actually want to be sharing data, but you're also like running some script over the top of it that like will plot it for whoever is visiting or whatever. There's like really cool things that you can do. And this is a service that we provide called Spin that allows you to build these kinds of web applications. It has access to our databases. You can mount access to, again, CFS. So it can be pulling data that you have stored at NERSC. So if you want to make like a cool website that shows your data in some way and you want to share it, you can do that using Spin. Um, so this Spin is in itself an entire training and several kind of hackathons and stuff. It takes is a little bit of a learning curve, but that training is incredible, and I really recommend it if you see yourself being like, oh, a lot of my data is going to be shared in like a database and I'd like to be able to share it with the world in XYZ way. I want to make a cool web application. You're going to want to use this because it makes it very easy to do that. Um, but then if you want to share large amounts of data with other people, not you don't want to just put it out on the internet. You want it to go to like a specific place, a specific person. You're sharing a large volume of data, right? So you've generated, CMB heat maps that you're, thousands or hundreds of thousands of these, and you're sharing them with your collaborators in Switzerland or whatever. You are probably going to want to use Globus. And the Globus is really well supported. It's a very safe way. It manages transfers for you. It'll tell you if things don't go wrong, don't go well, or whatever. And we highly recommend using Globus. Um, let's see here. Okay. We do have these specific data transfer nodes. These are nodes that are part of NERSC that are solely dedicated to this process of moving data around. So for example, if I need to, so SCP is secure copy from NERSC to my computer. I can specifically request one of these data transfer nodes instead of like just a regular Perlmutter login node. Um, because they're really optimized for efficient data transfer. And so they're in particular the capacity, the bandwidth capacity is monitored between some of these other facilities that you may be moving data between more likely than not. And these nodes are set up for this. So I have information here on how to do this for like smallish. So for a smallish file, if you're using SCP, you can just pick, okay, I want, to put this data here, and then you can go and copy it to, your now it will exist on your local computer, and I can use these data transfer nodes. Um, you can use it for large amounts of data, but I think in general use depending on the size of the data, you probably want to use Globus once you start getting to like huge amounts of data. But I also don't unfortunately have a good scale of like what is huge and what is not. So if any of our other experts want to give some context of like what's a large volume of data versus a small volume of data, please feel free to do so. Okay, and feel free to put it in the chat if you want to. Okay, I'm not going to go over this, but there are specific instructions for how to use Globus. Please, 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 please go to the docs page for the step-by-step. And this is literally like you're going to copy and paste exactly full how-to instructions. Do this, do this, do this. And it's so easy and it's very helpful. It's going to take you through this exact process. So I'm not going to go through it here because there's no reason to. You're going to follow these instructions and it's just going to work. So that's always great. Okay, we're not going to talk about that. Okay, so this is just kind of like this last little piece. This is meant to be my little like trying to sum up basically like everything that I told you about. Like, what are all these different types of storage? What are they used for? What's the data speed? What's the space? Everything like that. This figure is available in the Absolute Beginner's Guide. Again, like I said, I have been hyping up the beginner's guide because I wrote it. Hopefully it's useful. But obviously give me lots of feedback about that. But this is a good way if you're like, what are all of these different options? I just want to look at them all in one place. Would recommend taking a look at this figure because it kind of has like a little bit of information about each one that can help you orient yourself. Okay. Um, Happy to answer any questions. Any thoughts, comments, questions, concerns about data management? Okay, in the chat real fast, which storage space is not permanent? Which space is not permanent? Excellent. Wonderful. I see people writing Scratch. Beautiful. Thank you. Again, if nothing else in this whole training, we want you to remember that Scratch is not permanent.
There is no backup at all.
There's no backup. It's super good, it's super fast, but it's not permanent. Great.
All
Okay.
right.
Thank
Awesome.
you.
Thank you, Lippy.